All right, so in 5.2, we're going to do sum and difference identities. So, first of all, you have the sheet, theoretically, because I gave it to you before break. We've got the sine, cosine, tangent, and remember, I don't need to list the other three because I could always put 1 over sine, and that would be cosecant. So, what I have typed up is in terms of alpha, which is a lowercase Greek letter, and beta, which, guess what, that's B. And then these are not typos, so pay attention to how this is written. If I have the sign of, remember that this constitutes an angle measure. So if I have two angle measures that I've added together, then what I'm going to do is take these and I can break these down. And notice that on the right side, I have a plus minus as well. So I would read this as the sine of alpha plus beta is the sine of alpha times the cosine of beta plus, because it's on top, the cosine of alpha times the sine of beta. So now, why am I doing this to you? Because if you look at cosine, it's inverted. So if I have alpha plus beta, since addition is on top, when I move over here, it inverts. And so if I add two angles together on this side, I'm actually going to change it to subtraction on this side. So these aren't typos. These are legitimate identities. So again, alpha plus beta, since the addition is on top, pay attention to what's on top over here. For cosine, since addition is on top, pay attention to what's on top over here, which is subtraction. And then again, you could take tangent and realize that's the same thing as the sine over the cosine, or we can mess with it and drop it down into a simpler thing in terms of tangent. So, hang on, I'm going to shut this door. All right, so, and just to go on with chapter 5, you need to realize that a lot of chapter 5, since it's proofs, you're just going to have to kind of sort of fight your way through it. So I'm going over the broad aspect of each section. So I'm not going to do this to you for the rest of the semester. This is what we would be doing in class, is we'd be saying, okay, how do I get from here to here? So the difference is I'm on a video and you're not with me. So basically, here we go. So I need to look at this, and this is all that 5.2 is the sum and difference identities. So first of all, we need to recognize this says cosine, and I'm just going to say alpha. It says 94, but I'm going to say cosine alpha. And then notice that this angle measure is different. So I've got cosine alpha, cosine beta, plus sine alpha, sine beta. So what I'm looking for is the cosine, and then sine. So I know that this is going to revert back to, because I'm working on the right side this time, I'm going to revert back to what this says. So again, watch your signs. This is addition here. So where is addition on the right side? It's on the bottom. So what is that going to be on the left side? I'm going to change this into a cosine alpha minus beta. Okay, so I recognize the setup first. So my alpha is going to be 94. And my beta is going to be 64. So rewrite the expression as the cosine of a single angle. So this is going to be cosine alpha, cosine beta, plus sine alpha, sine beta, which is going to turn into cosine alpha minus beta. So all you have to do is subtract these two. So I could rewrite this as the cosine of 30 degrees. And then theoretically, you know what the cosine of 30 degrees is. So again, I didn't know what these are because these are not benchmark angles. But, all right. So the dog is gone. All right. So we should know what the cosine of 30 degrees is. And when I find out what the cosine of 30 degrees is, I remember it is root 3 over 2. Okay. So again, we're just going to have to sort of fumble our way through a few of these. So my mission on this one is to verify this identity. So sine alpha minus beta over sine alpha cosine beta equals 1 minus the cotangent of alpha times the tangent of beta. And so you just need to take the clues that they give you and say, how can I morph? And it flat out tells you on half of these. Write the left side numerator, which is sine alpha minus beta, in terms of the sum or difference formula for sine or cosine. So if I'm right now in the terms of sine alpha minus beta, come over here, I have sine alpha minus, your subtraction is on the bottom, so pay attention to what's over here. It's also subtraction. So that's going to give me sine alpha cosine beta minus, so I've got sine alpha cosine beta minus cosine alpha sine beta. Cosine alpha sine beta. And it says rewrite it by separating the denominator. Okay, so what does that mean? That means at this point, I have this entire expression over the singular denominator. So I've got two terms in my numerator. So term number 1 is going to go over the denominator, minus term number 2 is going to go over the denominator. So they already did the top part for me, which means all I have to write is sine alpha cosine beta, and then sine alpha cosine beta. Okay, and then what can I reduce? Well, sine alpha over sine alpha is 1. As long as your arguments match, it reduces to 1. So any number divided by itself is 1. Same thing. Any number divided by itself is 1. And then minus, now I've got a cosine alpha over a sine alpha. So my arguments match. So cosine over sine becomes cotangent. So that's cotangent. And then sine beta over cosine beta, sine over cosine becomes tangent beta. So the expression from the previous step simplifies to this mess using what? Well, what did we do? We didn't use even or odd, but we did use a quotient identity, because the quotient of cosine to sine is cotangent, and the quotient of sine to cosine is tangent. So we know that he's a quotient identity. So basically, that's what this entire section is going to be. So we just kind of sort of got to fumble our way through. So I'm just going to do a few of them. And then again, you can always email me and ask me for instructions. I'm limited to 15 minutes per video. And so I've got 8 minutes left. So I'm just going to sort of rip through this thing. So I've got sine alpha. In this case, my alpha is x, minus beta, which is pi over 4. So I'm going to rewrite the left side in terms of a sum or difference identity. So I see sine alpha minus beta. So sine alpha minus beta means I use subtraction on the right side. So I've got sine alpha, which is sine x, cosine beta, which is pi over 4, minus cosine alpha, which is cosine x, sine beta, which is sine of pi over 4. Then rewrite it by evaluating. Well, we know what the cosine of pi over 4 is. It's root 2 over 2. So this gives me the sine of x times root 2 over 2 minus the cosine of x times, what's the sine of pi over 4? It's root 2 over 2. And then can I fix this now? Well, what's common? I can pull out a root 2 over 2 from both terms. So that pulls out here, and that leaves me with sine x minus cosine x. So why was I able to do that? Because I undid the distributive property. Okay, so I pulled it out. They should have said factoring, but you're undoing the distributive property. So I need to find the exact value of the expression. So here's a trick. Always make sure they're not giving you something that you already know. So this says sine alpha plus beta. So instead of diving into all of the sum and difference identities, we'll add these together. That gives me the sine of 225. That happens to be a benchmark angle. So just because we're learning about sum and difference identities doesn't mean you have to use them. So I do know what the sine of 225 is, and that's going to be in quadrant 3. It's the same thing as the sine of 5 pi over 4. So that is going to be negative root 2 over 2. Okay, now this is the fun part. All right, we've got 105. I need to find two numbers that multiply, or sorry, that's a lie, add together to where I can get an answer of 105. And the two numbers that I need to add together need to be benchmark angles. Okay, so I don't necessarily have to add. I could subtract. So we're just going to find some friendly stuff. So what if I use 90? Because I know the sine of 90. 90 is a benchmark angle. That means I added 15. Well, that's not going to be right. What if we do 60? All right, so basically you're just kind of sort of wandering around. So let's try subtraction. If I've got the sine of, what's the next biggest, 135, okay? if I use the sine of 135, and then if I subtract 30 from that, what do you end up with? You get 105. So you kind of have to mess with this thing, find two benchmark angles that when you add or subtract them together, you get this answer. And so I saw that addition wasn't going to get me anywhere really pretty, really quick. It's not to say it wouldn't. In fact, I could have used sine of 60 and no, I couldn't have. Never mind. Ignore me. All right. So there's my alpha. There's my beta. Sine of 135 is going to put me in quadrant 2. So I just need to waddle on over here. Sine of alpha minus beta. And so that turns into sine of 135 cosine of 30 minus, and then I'm running out of room, the cosine of 135 times the sine of 30. So when I do this, what is the sine of 135? That's going to be a root 2 over 2. What's the cosine of 30? It's a root 3 over 2. Minus, what's the cosine of 135? It is negative root 2 over 2. And so that's going to change to a plus. And then what's the sine of 30? It is 1/2. So when you put this together, your common denominator is 4. Okay? So 2 times 2 is 4. 2 times 2 is 4. So your denominator is already there. Root 2 times root 3 is root 6. Minus root 2 times 1 is root 2. So that's really ugly, but that's about as basic as you can possibly get with it. Okay? So that is the exact precise answer. So now work backwards. This is sine alpha cosine beta. So you know that if you add those together, you get 30. And so you should be able to fill that one in. I'm trying to find unique ones so that I don't waste your time. You can do this one. This is going to be tangent. So watch tangent. If you have tangent alpha plus beta, notice that your numerator is tangent alpha plus tangent beta, but look what happens in your denominator. It inverts. So if it's addition over here, that means you look at the top symbol over here. So look at the top symbol here, that becomes the top symbol here and the top symbol here, which is subtraction. Okay, so just watch your signs on those. You're going to verify number 9. You're going to... These literally are pretty dang basic. That one's going to be interesting. Just remember when you look at this one on number 12 that this is an over 1 and that this is an over 1. Okay, so it kind of makes it a little bit easier to see. Because you can write cosine x times cosine y minus 1. So, in fact, let's just do that really quick. Cosine x times cosine y minus 1, you're going to distribute that. So that's going to give you cosine x, cosine y minus cosine x. And then notice everything is over y. Okay. This one will be minus sine x times sine y. So minus sine x times sine y. And then you can start putting this stuff together. So you'll notice that this part minus this part is one of these identities. And then you got this minus cosine x hanging off on the side. Well, there's your minus cosine x hanging off on the side, and guess what that one is? Okay, you're going to verify that one, and then these ones, because we love graphs so much, make sure that, so you're going to do sine alpha, sine beta, so you're going to add them, or add them, and just use the proper, build your triangles. On this one, build a triangle. Okay, that says build a triangle. On this one, the graph, shown to the right, so this is sine of x plus pi. And remember, this is your viewing rectangle, so this is far left of x, this is far right of x, and that's the increment. This is the lowest y, and this is the tallest y, and that's the increment. So that's your viewing window. Well, if this is 0, 0, I'm dropping down off of the origin, so we know that that's sine, and it got flipped. So I know that it's going to be this one. And then you just have to tell me which one matches this. How do I get from here to down here? Or here. How did I get from here to here? What's the intermediary step? Okay. And then the last ones are videos. So unfortunately, we're just going to have to kind of fuddle through 5, 1, 2, 3, and 4, and then we'll have much, much easier times in the rest. So don't give up.